All right, let's take a look at 18 here. Length of pregnancies are normally distributed with a mean 268, standard deviation of 15 days. If 64 women are randomly selected, find the probability they have a mean pregnancy between 266 and 268 days. All right, so there's one big difference here. We're looking at a sample now that we're talking about based on the population data, but we're looking at only this sample. So this is a sampling distribution. So when we go and calculate our z-values, now it's going to be x bar minus mu over sigma over the square root of n. So using the sampling mean there, the sample mean x bar, that's what we're talking about, the mean over there. And then we have to use a standard error because we are using a sample. Okay, so when we go and do the z for 266, we're going to do 266 minus 268 over 15 over the square root of 64. Okay, and that's going to come out to be about negative 1.07. The one for 268, well, realize that if I do 268 minus 268, 268 is the mean, so this is going to come out to be a z-score of 0. So then I'm really talking about, now that I have my z-values, I can do my standard approach. There's 0 and there's negative 1.07. I'm trying to do this area in here. Now, I already know the area below 0 was 0.5, and then I have to subtract what's below negative 1.07 to get that middle part there. So let's do norm dist negative 1.07 true. So that's the area below negative 1.07, and this time I'm going to do 0.5 equals 0.5 minus that because of the z-score of 0, and I get 0.3577. And that's B there. Okay. Use the central limit theorem to find the mean and standard error. Okay. Employees, the time, working for a company. All right, mean of 5.6 years, standard deviation of 1.9 years. Okay, that's from the population there. So that's a mu of 5.6 and a sigma of 1.9. And then random samples of size 18, so that's n is 18. Population and the mean of each sample is determined. Okay, so we're supposed to find the mean and the standard error of the sampling distribution. All right, so remember that mu x bar is going to be the same as mu. So mu x bar is going to be 5.6. Now the standard error, sigma x bar, is going to be sigma over the square root of n. So that's a 1.9 over the square root of 18. And from that, we should get about 0.45. So we have D here, 5.6 and 0.45. Scores on a test have a mean of 72 and a standard deviation of 12. Random sample 64. Mean and standard area, mean and standard error of the sampling distribution. All right, so they've told us that the mean of the population is 72 and the standard deviation of the population is 12. Again, easy to find the mean of the sampling distribution, that's the same. And the standard error would be sigma over the square root of n. So that's going to be 12 over the square root of 64, and that's 1.5. All right, so we got a mean of the sampling distribution of 72 and 1.5 for the standard error. If we did want to, so 72, 1.5, if we did want to sketch this, so we would have 72 there, and we'd know that one standard deviation above, we'd get 73.5. 2 above, we'd get 75. If we went one below, we would have 70.5, and 2 below, 69. Again, with a difference of 1.5 between every standard deviation. All right, critical value ZC that corresponds to a 98% confidence level. Okay, so again, we're talking about 98% confidence level. So we can think of this as 98% inside. Okay, so we're looking for the negative ZC and the positive ZC. All right, so 98% inside leaves 2% outside in the tails, or in other words, 1% there and 1% there. But again, we want to go to the decimal 0.01. And so really I'm going to find out what the Z value is at that point, and then just take the positive version of that. So now I'm starting with a probability and going back to the Z value. So I'm going to go in reverse. So 0.01. That gives me a negative 2.33. So that's negative 2.33. That's 2.33. So we get plus or minus 2.33. Margin of error.